All right, guys, we're back with part 2 of applying Ohm's law. And where we left off was we were starting the simulation here. We wanted to go ahead, I'm going to move this down. We wanted to go ahead and change the resistance here. Okay, so we click on the resistance. And again, like I said, resistance is going to affect the voltage and the voltage and the current. So let's say we change it. Let's say we have 100 here, okay? Let's just say that we made this resistor 100 ohms, okay? What happens if we change it to kilo ohms, okay? Wow, okay, that's really, really like, it doesn't light up at all, right? Well, what if we change the resistance? Like, how low can we go until we blow the circuit out? Okay, so 10. All right, so that's way too little resistance, right? We need way, way more resistance. Otherwise, we're going to blow out the circuit because there's too much current in there. So basically, here's the deal. What we need as budding electricians and electronics engineers is we need a way to understand how to figure out exactly what level of resistor do we need, for example, so that when we put current through to an LED light, we're not going to blow it out, right? So that's what I want to teach you now. I want to teach you how to apply that neato little diagram I showed you earlier here, the triangles, right? And what you're basically going to do here is you're going to look at this schematic here. And what you want to do is you want to think about, okay, you have 5 volts that's supplied here by the battery. It's shared by the LED, which is using 2 volts. So there's a 3 volt drop left, right? Because you take 5 minus 2, there's a 3 volt drop left over for the resistor, okay? Now, basically what you're going to do is you're going to calculate this based on what's happening through the resistor, okay? So you're going to go ahead here to your equation because you don't know what I is. You don't know what the current is, right? So you're going to say, okay, I is going to equal my voltage, which in this case is 3, and then resistance, my resistor measured in ohms is 220. So 220 divided by 3, right? And when we figure that out, we see that 3 equals I over 220, right? Okay, you find that I equals 0.0136, okay, in amps. But if we want to convert that to milliamps, because it makes it a whole lot easier to read, 13.5 milliamps is what we can have as a safe current, okay, for the LEDs. That's why we use a 220 ohm resistor, okay? That's why you have that. So in order to figure out what the current is here, we go ahead and we do that equation. By having 13.5 milliamps, like if I were to switch this here put the resistor back to 220, we can see that the current is 13.5 milliamps. So we know we're safe, okay? And that's what that allows us to do, to figure out, you know, what is the amount of current we can put through, what is the resistor amount that we need, amount of resistance that we need, so we can choose the proper resistor. That's what this allows us to do, which is pretty cool, right? I hope you think so. Maybe it's just me. All right. So I'm just skipping through some of these. And I just wanted to say, you know, congratulations, because we've gotten to the end of this. We've made this all happen. We've learned so much. And I want you to just, you know, play around with it here a bit. You are going to have a quiz. Your quiz is right here, almost right here. Your Ohm's Law quiz. So you're going to go into Google Classroom. Oh, I keep clicking on the wrong one for you, don't I? You're going to go into Google Classroom. You're going to answer these 4 questions on the sheet that I'm going to have posted there. And you're going to show off your knowledge, your newly found knowledge of electricity, electronics, and the fundamental laws of electricity. So congratulations, you've made it through the first 6 lessons in the fundamental laws of electricity, and you are well on your way to being a wonderful electrician and electrical engineer. Okay, good job. Bye.